last thing we need to learn about in this chapter is how to solve rational equations, which is usually the first thing we learn with new equation types. But it's kind of an afterthought in this because the graphing is so in-depth, and I want to make sure you could do that before we got into solving rational equations. So basically, you have three main options here in order to simplify these things into a solvable version of them. You can try to get a single fraction on both sides. So you've got a fraction equals a fraction, which will allow you to cross multiply. You can do that by getting common denominators and adding together. Or you could clear the fractions completely and then use your other solving techniques. So when you clear the fractions completely, you have like a polynomial equal to another polynomial, and then you just move everything to one side, get it equal to 0, and solve. Or you can get all the denominators to be the same, and then you'll basically just take the numerators and make an equation out of those. So I'll go through all three methods with a real basic example, and then I'll show you another example too. So the first one, let's say we want to try to just get a fraction equal to a fraction. Well, on my left side, I already have just one fraction. So that one's done. I need to combine the right side so that it's a single fraction. So what I'm doing is I'm adding fractions here. In order to add fractions, I need to have a common denominator. And I can tell that my common denominator is going to be 6. So I'm going to multiply this by 2 on the top and 2 on the bottom. This one's going to get multiplied by 3 on the top and 3 on the bottom. So what I end up with is the left side stays the same. The right side turns into 4a over 6 plus 3 over 6. Since these have common denominators, I can add them now. So I'll have 2a minus 3 over 6 equals 4a plus 3 over 6. And now I can cross multiply and solve. So if I cross multiply, I get 6 times this. I'm actually going to leave it factored out because it might make it a little easier to solve in the long run. 6 times the numerator over there. Now I'm going to divide by 6. The 6's go away. And that means I don't really need the parentheses anymore. I can subtract the 2a over here, which should leave me with 2a. I can subtract the 3 over here, which will give me negative 6. And then I'm going to get a equals negative 3 after I divide. Okay, so that's one option. Let's look at our next option. Clear the fractions completely and use other solving techniques. So I'm just going to move this answer that we got up here to make sure we get the same answer every time. And then I'll erase. I'll start fresh. So if I want to clear the fractions completely, what I'm going to do is I'm going to multiply by the denominator that will get rid of everything. So if I look, I've got a denominator of 2, 3, and 6. Well, I could multiply by each one of these. I could multiply everything by 6 times 3 times 2, and that would definitely clear all the denominators. But 6 will clear out all the denominators, because 6 will cancel the 3 and the 2 and the 6. So I'm going to multiply everything by 6. So here I'm going to have 6 times 2a minus 3 over 6 equals 6 times 2a over 3 plus 6 times 1 over 2. So if I simplify, those cancel. This will reduce to 2 and get rid of the 3. This will reduce to 3 and get rid of the 2. So simplifying gives me 2a minus 3 equals 4a plus 3. And then this is actually kind of the last step that we had when we got this answer. So I'll solve the same way. Subtract the 2a over, subtract the 3. I get negative 6 equals 2a. So a equals negative 3. Okay, so we get the same answer again. So let's do our last method here. So that's clearing the fractions out. It's two of the same answers we got. Let's get all the denominators to be the same, and then just set the numerators up as an equation. Okay, so if I want all the denominators to be the same, it looks like I'm going to want them to all be 6. So this is kind of similar to the first way we went. So I'm going to multiply this by 2, 2, 3, and 3. So I'm going to have 2a minus 3 over 6 equals, oops, 4a over 6 plus 3 over 6. Well, now that we've got all the same denominators, what's really happening here is, since I'm going to end up dividing everything by 6, I'm really just concerned about making sure that my numerators end up being the same. Because the only way that these two things added together over 6 equals this thing added, this thing over 6 is if these two things here, my two numerators here, okay, since they're both over 6, if I add them together, they have to end up being the same as what I have over 6 on the left side. So I get the same equation again, and again I would get the same answer. So you can pick any method you want. Sometimes it might depend on the problem that you're trying to solve. But all three of these will work anytime. So let's do an example more like what I'm going to expect from you. We've actually got some rational functions. Okay, because up here this is more of a linear type equation because I could simplify this. You know, I could actually put the 6 in here and I could turn this into 1/3 a minus 1/2 equals 2/3 a plus 1/2. So I could have turned it into that and solved. But here we've actually got some variables on top and bottom. So we can use the same methods. I'm just assuming most of you are going to want to clear the fractions because then you don't have to deal with them. So I'll show you that method. So in order to clear the fractions here, I'm going to have to get rid of an a minus 3 on the bottom. So that means everything has to be multiplied by a minus 3. I'm also going to have to get rid of this a plus 3 that's on the bottom. So I'm going to have to multiply everything by that as well. So I'll multiply each term by these two factors. So I'm going to have 2a minus 3 times these two. Okay, and that's over a minus 3. Okay, then we have 2 times these two. Okay, and that's going to equal 12 times those two over a plus 3. Now we can just simplify. This cancels with that. This one cancels with that. So I've got 2a minus 3, a plus 3, minus 2a plus 3, a minus 3 equals 12 times just a minus 3. Now we can distribute and use our normal solving methods because nothing else is going to cancel out of all three of these things. So if I multiply this out, I get 2a squared plus 6a minus 3a is plus 3a minus 9. Here I'm going to distribute these things together. If you notice, this is a difference of squares, so I know this is going to end up being a squared minus 9. And I have to multiply that by this negative 2. So that's going to give me a negative 2a squared plus 18. And that's going to equal 12a minus 36. So now if we combine like terms over here, I can see that my a squareds are going to cancel because I've got plus 2a squared and minus 2a squared. Negative 9 and positive 18 will turn into just positive 9. So now I've got this expression. I could have ended up with a quadratic here, and then we would use our quadratic solving methods. You could just as easily, if we had more complex denominators, you could end up with, you know, a third, fourth, fifth power polynomial, in which case you'd want to use our methods from last chapter to solve those when we used our methods for solving polynomial expressions and equations. But this one's pretty linear, so I'm just going to move the 3a over here, which will give me 9a. Add the 36 to this side, which will give me 45. Divide by 9, so I get a is 5. Okay, and those are the methods for solving rational equations. So you should be able to complete the last worksheet in your packet.